So in this figure, we're given the fact that this is a 30-degree angle, and we're trying to find x. They don't give us a whole lot else, right? Now, the fact that this is 90, and this is a linear pair, we could do 180 minus 90, and we get that this is 90 as well. So we have this as a right triangle, and keep in mind the concept that we have on side 4, so the back side of page 34 in our math reference document, where we know all three angles in any triangle add up to 180, and the corollary to that triangle sum theorem says that if you have a right triangle, then since this is already 90, these two have to add up to 90. In other words, they're complementary, so that the sum of those being 90 plus this 90 equal 180. So since this is 90, we know that these two angles are going to be complementary, meaning if you do 90 minus 30, you get this is 60. So great, we have a 30, 60, 90 right triangle. It's a special right triangle. Before we look at what is that relationship among those three sides, let's go ahead and observe the fact that there's a larger triangle as well. So really there's three triangles. There's the overall large triangle, there's this first one that we dealt with, and then there's this small one here that we haven't even discussed. Now, within this large orange triangle I have here, this is 30, which that angle B is the same angle B in both the overall large triangle and then that blue one we looked at. So the fact that this is 90 means that this is 60 as well. And then, since this is a right triangle, these two have to be complementary, so this is 30. So notice you have a couple of 30, 60, 90 right triangles. Now, let's go ahead to our reference document, which is up here in the corner. And notice we have the two special right triangles, 30, 60, 90, 45, 45, 90. Now, I do want to keep that in view to help us as we label things. And so what we're going to do is label the sides accordingly. So notice across from the 30, they label it as X. We're gonna look at the triangle first, where we already know a side, which is the overall large triangle. So notice across from the 30, we could label that as X. Across from the 90, they say is 2X. So across from the 90, keep in mind, they already have an X down there. I'm gonna go ahead and label this overall side as 2X. Probably should have used a different variable because there already is an x, but we'll look over that. And then across from the 60, x root 3. So across from the 60, x root 3. So let's clean up some of that so it's not too messy here. And the fact that we know that this x is 4, well then that stands to reason that 2x is 8. And then really this side is going to be that 4 for x root 3. Okay, wonderful. Now, the fact that we're really trying to find this x right here, we got to think about what we could do there. Well, if I can figure out what this shorter side is, I can subtract it from 8, the overall side length, and I'd be left with x. So how can I figure out that question mark? Well, remember we have another 30, 60, 90 triangle in this smaller one right here, this triangle. And so across from this 30, I could label it as x, but that'll be confusing. So let's just call it y. Across from the 90, we'll call it 2y. So we previously called it x, but now we'll also call it 2y. And then across from the 60, we'll say y root 3. Now, if 2y is 4, then y is 2. And then since this whole length is 8, 8 minus the 2 leaves us with 6.